All right, people. So, acids. Now, our understanding of acids is going to change as the course progresses. But for now, what I want you guys to think of acids, whenever you see a compound that starts with H, I want you to start thinking acids, all right? The first definition of an acid has to do with hydrogen. And let's just say as soon as you see a hydrogen up in the front, you know there's an acid. So like HCl, H2SO4, H3PO4, HIO3. As soon as you see an H in the front, whether it's a binary or whether it's a polyatomic, you should be thinking acid. Now there are a few exceptions, for example, like these two. And there's other ones, but these don't have acid naming systems, but it's okay. But there's two main types of acids we're going to talk about. There's what you call binary acids, and then those that are called oxyacids. Now, oxyacids, the name kind of says it. Oxy has oxygen in there. And where do those oxyacids come from? Well, they come from the polyatomics. So oxyacids are a hydrogen or a hydronium. You'll learn about that. But there's an oxyacid is caused by a polyatomic ion with a hydrogen. All right, and binary acids are it's hydrogen and then one element. All right, so it's going to be a non-metal. So it's going to be one of these right here. So hydrogen and N3, it could be H3N or H3P or HCl, HBr. So hydrogen and one other thing is a binary acid. There's a few exceptions to the binary acids. For example, cyanide, because you see it's in the polyatomics, but no oxygen, so it's not an oxyacid. And then thiocyanate. Since there's no oxygen, it's not a oxyacid. So these are going to follow the same rules. And we're going to talk about those rules today. All right. So let's check it out. So a binary acid is very, very simple. A binary acid has this basic template. It's hydro blank ic acid. Whenever you see H and one element, you're thinking hydro and then the name of the element. And you change the ending to ic and write the word acid. So for example, HCl, pretend you don't see this. You see H, you're like, oh, that's an acid. Well, how many things is it with? Well, it's only an atom. So that's binary. So it's hydro. What's the name of the element? Chlorine. Change the ending to ic. Hydrochloric acid. All right, let's check out another one. So HCN. So there's hydrogen, so you know it's an acid. So you're going to have hydro. Now CN, there's no oxygen. There's no, sorry. Whoops. I'm about to sneeze. Bless me. I didn't hear you. Bless me. I'm not going on till you. All right. So, since there's no oxygen in there, it's going to follow the hydro rules, right? So it's going to be hydro blank ic acid. All right. So CN is cyanide. We change the ending to IC, hydrocyanic acid. And that's it. That's it for these. This one right here. There's H and no oxygen. So it's going to be hydrosulfuric acid. Now, sulfur is a special case because when you drop the ending, you have to add the UR right back. I would write this down on your notes right now. You would add the UR, and with phosphorus, you add the OR. All right, so phosphoric acid. You don't want to just drop off the last bit of the name. Not hydrosulfic, not hydrophosphic. It's sulfuric and phosphoric. All right. So now if we're talking about oxyacids now, if there is an oxygen, it's an oxyacid, and that's going to be determined by the ending. There's two main endings. There's the ATE and then there's the ITE. The ATE becomes IC and the ITE becomes OUS. Those are two things you might remember, or you should remember, or should try to remember, or should try to master. Ate to ick. So the mnemonic device is you ate something icky and got gingivitis. All right, so that's just if you want to remember that. It might help. On a test, Hail Mary, I didn't study, ate something icky, got gingivitis, and you might get lucky. All right, so how do we use that mnemonic device? Well, when we see something like HNO3, pretend you don't see this. You know H is an acid, so we got to follow the rules. Then we check, oh, there's an oxygen. Well, if there's an oxygen, what you got to do is figure out what that thing is called. NO3, if we look at our table of polyatomics, is called nitrate. And we remembered that silly mnemonic device that told us ate something icky, and we change ate to ick. So now it becomes nitric. And since it's an acid, we add the word acid to it. And nitric acid is the name. Ah, look at that. You would have never known. Let's do the same thing with H2SO4. We know H, it's an acid. So then we look, there's an oxygen. It's an oxyacid. Well, SO4 is called sulfate. Then we got to change the ATE to ick. So it becomes sulfic. But Mr. Sanchez said something about sulfur. It keeps the UR, so it's sulfuric. And since it's an acid, we got to say it's an acid. So sulfuric acid. Now this one right here. So H, there's an acid. Well, what the heck is all of this? Well, there's still an oxygen. It's the same thing. This is called acetate. You change the ATE to ick and call it a day. All right, that's how you go from the formula to the name. All right, so CVH, it's an acid. If there's an oxygen, you got to use ATE or ITE. I think the next slide we're doing ITE. All right, so if there's an oxygen present, you look at the ending. NO2 is nitrite. Well, we got to change the ITE to OUS, gingivitis, right? So nitrous, and then since it's an acid, just add the word acid, and boom, you're done, you're finished. That's pretty simple, I think. I'd like to think that's simple. If you don't think that's simple, look at it differently till you do think it's simple. Practice till it becomes simple. H, it's an acid. SO3, that's sulfite. We got to change the ending to OUS. Then we call it sulfus. And then we're like, something's not right. Mr. Sanchez said that whenever we got sulfur, we got to add the UR. Sulfurous acid. I'm taking extra points if you don't add the UR, all right? And phosphorus with the OR. Don't forget about that OR. So, that's basically it. All right? No hydro. If there's an oxygen present, there is no hydro at all. All right? And the opposite works too. If the word says hydro, that means you're not looking at your polyatomics, or you're not looking at something that has oxygen, okay? Hydro means no oxygen, all right? And then if there's an oxygen, then no hydro. Let's think of naming these in reverse, right? Or going backwards. If you got you got the name. Now we got the formula. Now we're getting the formula. Carbonic acid. Well, there's no hydro, so I know there's going to be an oxygen. All right, the next thing I do is I look at the ending ick. Ick came from something I ate, right? You feel icky, it came from something you ate. Well, that's carbonate. All right. And since it's an acid, every acid has H involved. So H is plus, and then carbonate is CO3 negative 2. Because once you know the name, you can go to your polyatomics and go find it. Well, how many H's to balance out that negative 2? Well, you need 2 of them. So the formula is H2CO3. And that right there, that's your carbonic acid. That's what's in your soda. That's what makes you burp. All right? And that's basically it. If you need another example, I'll do another example just for you. Just because you asked. Just because you said it. Mr. Sanders, could you do another example? For you, yes. For anyone else, no. Don't tell other people watching this. So let's take a look at this one. Hypochlorous acid. Well, hypo means no oxygen, right? Wrong. Hypo means something else. Hypo means less oxygen, but there's still oxygen. All right, so we can look at the table. Let's look at the table. Okay, let me erase this because someone made a mess here. Oh, someone made a mess. So hypo, this is alphabetical order. So if you see it, alphabetical order, right here, hypochlorite. So you're using ClO. So we write that down. So ClO minus, and we know since it has an acid, it's H plus. So how many pluses do we need to balance that out? We just need that one. So the formula is HClO. Nice little box. And boom, there you have it. And that's it, people. That's what you need to do. Farewell. Hasta luego.